Hello, everyone. Welcome back. Today, I'm going to be talking about factoring quadratics in standard form, part 2. Last time, we specifically looked at how to factor quadratics with standard form when our a value is 1, right? So when we just have x squared plus blah, 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 right? Today, we're going to look at what if it's not just x squared, blah, blah, blah. What if we have a coefficient with our x squared? So this first one we have 2x squared, the second one we have negative 6x squared, and so on. How do we solve it? Or not solve it, how do we factor it in this case? I'm going to get into that. Okay, so if we recall, let's say that this was just, there's no 2, we just had the 6 and the 7. Well, then I'd be saying, well, what we need to do then is we need to find something that multiplies to 6, two numbers that multiply to 6, and add to 7 in that case, right? However, in this case, we do have the 2. So what I'm going to do is I'm actually going to multiply the 2 and the 6 together. So we're going to multiply a and c together. 2 times 6 is 12. And I'm going to find two things that multiply to 12 and that add up to 7. Okay, so similar to the steps in the last one, it's just that now that our a value isn't 1, we have to multiply our a and c value, right? And in a way, we did that in the last one, but the a value was always 1, and so it would end up just being the c value anyway, right? So it didn't matter. Okay, but now let's move on to the second step. We need to find two things that multiply to 12 and add to 7. Now recall that whenever we're finding things to add to 7 or any other number, there's so many possibilities, right? It's very hard to figure one out that's going to end up multiplying to 12 as well. Whereas when it comes to multiples of 12, there's only so many factors that 12 has, right? Or sorry, I said multiples of 12. No, I should have just said factors of 12. There's only so many factors 12 can have, and so it's much simpler and easier to just focus on that. So that's what I'm going to do. Also, I want to note that 7 is a positive number, so I'm only going to put positive values here. I'm not going to bother with negative values because no two negative numbers are going to add up to be a positive number like 7. Okay, so let's do that. I have 1 times 12. Let's see, 2 times 6, 3 times 4. Oh, 3 times 4. Well, that could work, right? 3 plus 4 is equal to 7. Awesome. All right, so now what's my second step? Well, I'm going to separate this into 3 and 4, like that. Okay, and now I can partial factor the first two and partial factor the second two. I know how to factor this by grouping. If you don't recall how to factor by grouping, that was actually 2 sessions ago. We talked all about factor by grouping. But now we're learning, well, how can we actually know what to separate, what to group together? Well, here's how we can do it, right? We can figure this out and then separate them and then factor by grouping. Okay, but just a quick reminder, I will go through it briefly now because I know we did just talk about it one other time and that was it. We need to common factor the first two terms, and then we need to common factor the second two terms, or sorry, the last two terms. So how do we common factor 2x squared plus 4x? Well, we're going to common factor out a 2x and get x plus 2 like that. And then for the second part, we're going to common factor out a 3. And then now that we've common factored both, we're going to, from the full thing, common factor out the x plus 2 from the 2x and the 3. And there we go. There's our answer. Now we fully factored it. And something I mentioned previously, but I want to mention again, is that we did not actually change the equation. When we factor, we don't actually change an equation. We just change the form of an equation. This is the same thing as this. It's just that they're written in different formats, right? Sometimes it can be useful to factor because it's a question on a test, but other times it's useful to factor because we actually want to solve an equation. And sometimes it can be easier to solve an equation if we first factor, right? That's one way to solve an equation. So there we go. All right, I plan to go through a few more examples here. Let's move on to example 2. So I need to find two things that add up to negative 16 and that multiply out to negative 36, right? Negative 6 times 6, A times C, is negative 36. So what are my possibilities? Well, let's see. Negative 1 times 36, 1 times negative 36, um, negative 2 times 18, and 2 times negative 18. Now, I will say there are more, but I'm actually going to start getting to the habit here with these of stopping as soon as I see the correct one, because I'm not going to give you any points for, just writing out the full thing. I only really care about the one that's the answer. And I can already tell here that this one here, the 2 times 18, or 2 times negative 18, is the answer, right? Because 2 plus negative 18 is negative 16. So automatically there, that's our answer. We're good to go. So now I know where to separate this. I know we can separate our negative 16 to 2 and negative 18. And now we have something where we can partial factor, right? We can factor out, we can partial factor, or sorry, I shouldn't say partial factor. That actually means something different later on. But we can common factor the first two terms and common factor the second two terms, and then factor by grouping. So let's do that. This is equal to, let's see, negative 2x times 3x minus 1. And then with this one, we have negative 6 times 3x minus 1. And then we can finish that off and say this is the same as 3x minus 1, negative 2x minus 6, like that. And we can actually factor slightly further than this. I probably would accept this as the final answer, I will be honest, but I'm just noticing here we can actually factor a negative 2 out of here, like that. And so that would actually be the fully factored form, because one of our brackets, I've noticed, we actually have another common factor that we didn't deal with before that we can factor even further. Although that said, I probably would accept the previous line as the final answer as well. Awesome. Okay, let's move on to number 3. So this time we need two things that multiply to negative 30 and add up to 13. Okay, so let's see. We have negative 1 and 30, 1 and negative 30, negative 2 times 15. Oh, that's the answer. I'm going to stop there because I found my answer. And now let's separate them. 6x squared minus 2x plus 15x minus 5. And now we're going to common factor the first two terms and get 2x times 3x minus 1. And then over here, I'm going to factor out a 5, like that. And then I'm going to finish up the factoring by grouping. And there we go. We did it. And you know what? That's the great thing with factoring. The hard thing about factoring, there's so many different methods of factoring, and there's more after this, by the way. This is not the end all be all. This is, I'm not going to say it gets harder than this, but there are certainly more methods than this. But once you understand all the ways to factor and also know how to recognize how you should factor, then it's not so bad after that, because you'll notice for all of these, it's the exact same steps over and over and over. We're about to do these same steps again. All right, so let's do these same steps yet again. Number 4. Oh, and something I should mention too is, and I didn't do this up here for number 2, and I should have actually, is there's something I like to say, always common factor when you can. When you're able to common factor in the beginning, then always do so. Absolutely always do so. So this one here, actually, we can kind of treat this the same way we treated one of the previous ones, because this is the same as 2 times x squared plus 5x plus 6 right? And then this we can just factor and say, okay, what are two things that multiply to 6 and add up to 5? Well, 2 and 3. I wrote 2 plus 5 there, my apologies. 2 plus 3. So this would just be x plus 2, x plus 3, like that. We can do it that way. Or we could do it the factoring by grouping way. However, this only took me 2 steps. The factoring by grouping way took me three steps, or in this case 4, because since I didn't common factor earlier, I ended up just having to common factor at the very end instead. So always common factoring when you can make things a little bit easier. So if you have the opportunity to make this an easier question for yourself, absolutely do that. Okay, mathematicians are lazy. Well, I shouldn't say that. I shouldn't encourage laziness. But the point is, if there is a path of least resistance, if there's an easier way to get to the same results, absolutely go for it, right? There's no point in doing extra work just for the sake of doing extra work. It's important to be efficient and do the work that is necessary and do that work fully, but no point in doing anything that's extra or not really relevant to the problem that you're trying to solve. So I don't view it as necessarily being lazy, but being efficient and effective in your work, I think is good. And if that means, ending up doing less work, fantastic. Okay, let's do one more. Now this one we can't common factor. So we're just going to have to find two things that multiply to negative 11. Multiply to negative 60 and add to negative 11. So let's see, we could do negative 6 times 10. Nope, that doesn't work. 10 times negative 6 also is not going to work. Oh no, that's the same thing twice. I meant 6 times negative 10, but I mean, that also doesn't work. That's going to be negative 4 if we add those two. What else? Let's see, what about 9 or 8? Nope. 11, 12. Oh, yes, 12 times 5. That's not going to work though. Okay, what about 13, 14, 15? 15, that works. And here it is. 4 plus negative 15 is negative 11, and 4 times negative 15 is negative 60. There we go. We did it. Okay, so then we have 6x squared plus 4x minus 15x minus 10. So then we have 2x times 3x plus 2 minus 5 3x plus 2. And then here we have 2x minus 5, 3x plus 2. And there we go. We got it. All right. Well, good work today, everyone. I hope this helps. I hope this was clear with kind of the progressions. This is very much a combination of what we did in the last two times, right? We did this method, and then before that, we did factoring by grouping. And if you put those two things together, and also if you know how to multiply two numbers together of A and C, then you're good. You're good for this. I would say this is not the last factoring method that we will talk about. This is probably the hardest one and the one that has the most steps to it. And yeah, we will. We'll continue with some more examples of this in the future. And also, we'll learn more factoring methods in the future, too. But if you understand the last two parts really well, then and you put these together, practice some of these, you're going to be good to go. I do suggest doing a lot of practice, and I do have some suggested practice for everybody as well. Because practicing with stuff like this, that's just the same over and over, is really the key here to mastering it. So, good work today, everyone, and I will see everyone back next time. Bye, everyone.